Hey guys, how are you doing today? So, in this session, we'll talk about Oracle database storage layers that are involved, and as a developers, what layers do we interact with or do we look at, and what are the further layers that are maintained by the database administrators, right? So, as we can see, this is one of an image that I have created for internal reference. And if we look at like ORCL is one instance of a database. Let's say that like I have an Oracle database and I can install it and configure multiple databases inside the Oracle technology. However, ORCL is one of the instance. In this case, I'm taking as an example. And within this database, when I configure, so what do I need to configure along with. So there's something called table spaces, which are the ultimate layers where the data gets stored, right? So if you go all the way from top to bottom, so in a database, whenever we want to create a table to store the data, we will be creating in certain schemas, right? So if we do not specify any schema name while creating, it gets stored inside the schema, whatever the user, a database user has logged in, or we can always specify a schema wherein which the data has to be stored. I mean, the table has to be created. So let's assume that we wanted to create an employees table in the human resource schema, which is nothing but HR schema. We can create it, and this HR schema should always be tied to some table space, which is essential to indicate where exactly this data is going to be stored. The reason for this is, let's say that we want to store the data in the database, but ultimately it has to be stored in the physical hard disk drives, right? So if the data has to be stored in the hard disk drives, it has to store it again in the form of files. So how database knows exactly in which file the data has to be stored? So that's where the table space comes into picture. Whenever we create any table within a schema, if the schema is associated with a table space, and as a developer, if we do not specify any table space name, by default, the table gets associated and stored into the respective table space that is assigned to the schema. However, we can also specify in which table space the table has to be stored in case if we want to store the table in different table space. In fact, we can specify that. So now, as we are looking at, so I have two schemas. One is HR and the other one is sales. Within HR schema, I have employees table, and within sales schema, I have products table, and they both have their respective table spaces, and each table space will be associated to a data file. We call it as data file, which gets stored in the physical disk as a physical file. And all the database files will have the extension of .dbf. And as we can see here, hr underscore table space has hr underscore table space .dbf. This is the file where the data gets stored ultimately. However, a table space doesn't directly store it as it is. In between, it has a concept called segment, which means that like for a given table, it always has a segment that gets associated until unless we have really large files that are getting stored in the table. As long as you have a rows within maybe like variable character or number formats or integer formats, then it will always have one segment, and a segment can have multiple extents, and each extent will have a set of blocks. So ultimately the block is the place where the data is getting stored. So when we create a table and insert the data into the table, it goes to the table space, and then it will find out and allocates a segment. The segment will have one or more extents. Each extent will have set of blocks, and as I mentioned, block is the least unit, memory unit where the data gets stored. And these blocks are actually sitting in the file system of your hardware. It's not just part of database, but it is your hardware. So this is where the data gets stored, and all of this is getting stored in the file system as one database file .dbf. So whenever we configure an operating system, we always have the concept of block size, which we can specify what should the block size. If your block size is too less, and if you have large data, then it gets stored across large number of blocks, which means that your retrieval is going to be slower. At the same time, if you have larger block size and your data size is less, then you're going to read entire block even to read a single row. That again will lead to performance issue. So we should always find out the optimal block size which can be used to store a row, so that entire row will fit in one single block, and when we want to read, we can only read that particular block instead of reading multiple blocks in case if the block size is less, or instead of reading a block which is really large and has several other rows which are not of our interest, right? So that's about different storage layers that are involved within the database architecture. In case if you have any questions, feel free to ping me in the comments and I'll try to answer it. And part of our next session, we'll talk about how to create the tables, what are the different parameters that are involved. As I mentioned over here, like when we create the table, we are specifying the table space, and also we'll see how to specify it and what is PCT free segments, and and then like we have other parameters which we will deep dive more. And until then, take care. Have a good day. Bye bye.